Howdy, this is our MXET 300 final project idea. We call it Circle Chromatically Integrated Robotic Cornering and Localization Engine. This is our final project and we are section 505. The team members consist of Tyler Lamb, Annabelle Fish, Evan Dixon, Himesh Patel, and Cole Wieters. We are group 2 on Canvas.
For this project, we proposed to design an autonomous scuttle robot capable of intelligently sorting objects. The system will use computer vision, specifically color detection, to recognize four different colored blocks or balls within its environment. Based on the detected color, we will implement decision-making logic that allows the robot to determine the correct action for each object. This will enable fully autonomous operation without user intervention. The scuttle robot will be designed to navigate towards objects, grab them, and securely pick them up for transport. Finally, the robot will deliver each object to a designated location that corresponds to its color, completing the sorting task. This project aims to demonstrate an integrated system combining sensing, control, and actuation in a fully autonomous robotic platform.
In the next phase of our project, we will ensure that the scuttle can operate reliably in dynamic environments. To achieve this, we plan to implement obstacle avoidance capabilities so that the robot will be able to detect and navigate around unexpected barriers while still completing its sorting task. Our design will integrate the core elements of a mechatronic system. For actuation, the scuttle's drive motor will handle navigation, and a dedicated pickup mechanism will be developed for grabbing and lifting objects. For sensing, we will rely on the onboard camera, which will provide the visual data needed for color detection and environmental awareness. All of these components will be coordinated through autonomous control logic. The robot will continuously process sensor inputs, make decisions, and execute movements in real time, demonstrating a fully integrated mechatronics approach.
Howdy. So for the execution of this side of the robot, we have three main parts: detection, movement, and arm. For the detection, it has two main things: color identification and corner identification. For color identification, the robot is able to detect the color of an object and based on that, go to that specific corner designated for that color. Now, for the corner identification, it needs to be able to get to that location for which we have movement. The movement is controls our motor control, global reasoning, and dynamic object avoidance. With motor control, we can measure how long it needs to go, how far it needs to go, and also what paths might come in its way with the dynamic object avoidance. And then with the global reasoning, it has its location base, so it knows that it has reached its final location and then can go back to pick up the other objects that might be in the center. And then to pick up these objects, we have the arm. The arm is is focused on picking up the object and then holding it before dropping it off in the corner.
So for the timeline, we're projected to work on this presentation the week of the 22nd. And along with our previous lab being the color tracker, we're going to carry on that progress into the upcoming weeks. So this upcoming week, we are going to be working on the color tracker, corner identification, movement algorithm, and robotic arm all simultaneously. And we're going to work on those up till about week 3. And then we're going to concentrate on the movement algorithm and robotic arm, along with the application of all of these different systems working together. And then finally, by week 5, we're going to work on our demonstration and presentation. For the roles that are going to be taken during this project, we're going to have Tyler Lamb on color tracking, Himesh Patel on corner identification. I'm going to work on movement, and Annabelle Fish and Evan Dixon are going to work on the robotic arm.